In this video, we are going to explore the importance of each part of our functions that are trig functions where we have a change in a coefficient prior to our function. We might have a coefficient that acts on our variable, and then we have another variable that is within that same argument. This is the graph of the trig function, just the regular old y equals sine x. So notice that from negative pi over 2 to pi over 2 down to 3 pi over 2, our function makes one complete cycle. This one cycle is called our period. So from low point to low point, again, notice we're going up from this low point, up from this low point. We call this one period, and in this case our period length is 2 pi. We also call the distance from our top most point to our bottommost point, so our max function value and our minimum function value. Half of that is going to be called our amplitude. So some important words. Amplitude, which is the average of our maximum value minus our minimum value. We have our period, and then we'll eventually talk about something called a phase shift. Each piece of our function is important. This coefficient here that we call a, this changes our amplitude of the function. So the amplitude of our function will be defined as the absolute value of this a. And again, this is only going to happen for sine and cosine functions. Does not happen for any of the other functions. So in this function, there are some important things that I want to point out. We can see that this goes up higher. What you would be able to see is that each of these is marked 1. And then down here they're -1. So we can see that this distance from our maximum to our minimum has changed. And our amplitude of this function is 3. This is actually the function y is equal to 3 times the sine of x. So all that has changed here is the vertical stretching of our graph, so that it now reaches 3 and -3 as our maximum, 3, -3 as our maximum and minimum function values. So in our first graph of the sine function, the period was 2 pi, meaning that the function repeated every 2 pi radians. What we see here, though, is that here we have the function has a 0 and it's going up. Here the function has a 0 and it's going up. And the distance between these 2 points is actually going to be pi units. So in this case, our period for our function is pi units. So what b does is that it modifies the period of our function. So we do this by taking our normal period, which is 2 pi, and dividing it by b. So this is actually the graph of y is equal to sine of 2x. We can see then that 2 pi divided by 2 is equal to pi, which gives us our period. Some important things to note. B is always positive. It's always greater than 0. If B is strictly between 0 and 1, then the period is longer than 2 pi. It stretches out our graph kind of like a slinky. However, if B is bigger than 1, as we can see from this example, then the period is shorter than 2 pi. So it kind of compresses that slinky. So we're going to see an example next where that is the case, where we have actually lengthened our period. So what we can see here is that actually from this low point going up, which I can mark here, low point going up, to this low point going up, we actually have a distance of 4 pi. This is again a sine wave. So what has happened here is this is y is equal to the sine of 1/2 x or x over 2. So notice that when we take 2 pi divided by 1/2, that's 2 pi times 2, which is 4 pi, which elongates that period. And we see exactly what I talked about last time. It's like stretching out that slinky. So we've talked about what A and B do. Now it's time to talk about what C does. This actually creates what we call a phase shift. And what it does is it actually moves our graph. It's picking up the graph and actually shifting it along the x-axis left or right. Some things I want you to notice. This is a minus sign, which means that C is positive if that minus sign is there. So what you need to know is that if C over B, and again, B is always positive, is greater than 0, we have a right shift of this amount. If this ratio C over B is less than 0, we have a left shift that same amount. So let's look at an example. So what we can see here, first I'll sketch in the normal sine curve. So remember, sine starts at 0, at pi over 2 it goes up to 1, then down to 0, down to negative 1, up to 0, back here it's at negative 1. So our sine curve essentially looks like this. We can see that it is not in sync with the purple that was already present. So what happens is there is a shift. We can see that it is a shift in this direction to the right. And I labeled the points for you so you can see that it is a shift to the right of pi over 4 units. So this means that C over B is equal to pi over 4. The period, however, let's look. We start here at negative pi over 4. We go to 7 pi over 4. So this distance using our period is actually still 2 pi. So we know that B equals 1. So C must equal pi over 4. So our function is y equals sine of x minus pi over 4. Again, that minus sign is there because it's here in the original. So C must be positive. The ratio C over B must be positive. It is a shift to the right. The cosine functions behave exactly the same way. The absolute value of A is our amplitude. B is always positive, and we know that 2 pi divided by B is the period of the function. Again, this is a minus sign, and from here we know that the ratio of C over B is the phase shift. So what I want you to know from this is if we were to have the function y is equal to 6 cosine 3x plus pi over 2, I'd want you to be able to tell me exactly what the amplitude, period, and phase shift would be for these. We know that this is going to tell us our amplitude. It's the absolute value of 6, which is 6. We know that our period would be 2 pi divided by B, which is 3. I'll write these up here so that you can kind of see what they are still. Minus c. Our period will be 2 pi over 3. And our phase shift, so this is where it gets a little weird. Remember that in this case, c is equal to negative pi over 2. B was 3. So our phase shift is negative pi over 2 divided by 3. So that's negative pi over 2 times 1/3, which is negative pi over 6. So it is a left shift by pi over 6 units.